Hi dear student, this is Sanal from Heal Body Classes. Welcome back to AS Level 9702 series. In the last video, we have practiced 5 very good questions from uncertainty calculation. I hope you guys practice those questions. In the same way, we are going to practice 5 MCQ questions from uncertainty calculation. Okay, when I give the question like last video, you should pause the video and try to do it by yourself and check your answers. If you are getting all the 5 answers correct, that means your uncertainty concept is strong. Let's start the class. First question. You read the first question. Two quantities are measured, A and B. The measured value is given with its absolute uncertainty, and it is used to calculate a quantity Q, A minus 3B. So question is, what is the absolute uncertainty in Q? Okay, you pause the video and try to do it by yourself. Now I am going to solve this question. So this question, when you check the equation, the operation done is subtraction, right? What is the rule for subtraction? The absolute uncertainty in the quantities should be added up, right? So when you check this quantity, A is measured with absolute uncertainty. So delta A is the absolute uncertainty in A, and delta B is the absolute uncertainty in B. But in the equation, the B is multiplied 3 times. That means you need to multiply this equation by 3 times, right? So the absolute uncertainty will be multiplied by 3. So what is the total uncertainty in Q? Q will be absolute uncertainty in A plus 3 times absolute uncertainty in B, right? So absolute uncertainty in A is given as 0.4 plus 3 times absolute uncertainty in 1, 0.1. So it will be 0.4 plus 0.3, which is equal to plus or minus 0.7. We check the option. Option C will be correct option. Let's move on to the next question. Second question. So you read this question, pause the video and try to do it by yourself, okay? Take a screenshot and solve it. So now I am going to solve this one. Q is equal to x minus y by z. So a quantity is given x minus y upon z. And the measurements taken x, y, z are given with its absolute uncertainty. What is the percentage uncertainty in Q? So when you check the equation, what operation is done? It is division and a subtraction is there. It is a combination question, right? So you need to find out the percentage uncertainty in Q. Okay. So fractional uncertainty in Q, delta Q by Q, will be equal to fractional uncertainty in x minus y plus fractional uncertainty in z. See, if you multiply by 100, you will get the percentage uncertainty, right? So first we will check what is the fractional uncertainty in x minus y. Fractional uncertainty, x has absolute uncertainty 0.3 and y has an absolute uncertainty 0.2, 0.2, right? So this operation is minus, so you need to add both uncertainty. So rule number 1 we will apply here, 0.3 plus 0.2, which is equal to 0.5. Understood? Now you can check what is the fractional uncertainty in x minus y. X minus y, delta x minus y by x minus y, which is equal to 0.5 upon 0.5 upon, what is x minus y? X minus 4, 6 minus 4. So this will be equal to 0.5 upon 2. So when you put this in your calculator, you will get 0.25. So that is the percentage uncertainty in x minus y quantity, right? Similarly, you can find out the fractional uncertainty in z. Delta z upon z will be equal to 0.1 is the absolute uncertainty in z divided by z value, which is 1.5. When you put this in your calculator, what is the answer? 0.06, right? So what is the total uncertainty, fractional uncertainty in delta q upon q, which is equal to 0.06 plus 0.25, which is equal to 0.316. Right? This is the fractional uncertainty. The question is, what is the percentage uncertainty? You multiply this with 100, you will get the percentage uncertainty. So it will be 31.6 percentage. So when you check this one, so this is the closest value, right? So answer will be D. Next, we will move on to the third question. So this is the question. Take a screenshot and try to do it by yourself and check the answers. Okay, after that only you will watch the solution. The density is calculated using rho is equal to m by r square h. Okay, the percentage uncertainty is in m, r, h is given. What is the percentage uncertainty in the density? For the percentage uncertainty in rho, you can check that delta rho by rho into 100 will be equal to percentage uncertainty in m, delta m by m into 100 plus delta r by r into 100. This is the percentage uncertainty in measuring radius, right? But this radius is squared. Squared means what? You need to multiply with the 2. Most of the student will make mistake here. Take care of the power always. Power is always get multiplied. Here also power is 1. Here also power is 1. You are multiplying it, but since it is 1, we are not writing it. Okay. Then what is the next quantity? H, right? Plus delta h by h into 100. So you have added all the percentage uncertainty. So you know that the percentage uncertainty in mass is given, radius is given, height is given, right? You substitute those values, you will get it. 1.0 plus 2 times what is the percentage uncertainty in measuring radius? It is 0.8 plus what is the percentage uncertainty here? 1.2 percentage, right? So when you add everything, you will get the percentage uncertainty in measuring the density. So you add this in your calculator. So it will be 3.8 percentage. You check the options. The option A is correct. I hope you got this question right. If you got this question right, just comment in the comment box. So we will move on to the fourth question. So take a screenshot and do it. Then you watch the solution and check whether you got the right answer or not. Okay, I'm going to give you the explanation. Two quantities x and y are measured, whether their uncertainty value, absolute uncertainty value is given, which statement is correct. Okay, in this type of question, you need to read all the options and eliminate the wrong answers first. Okay, so x is definitely greater than y is definitely greater than x, the value overlaps and may be equal, uncertainty is too large to compare. Okay, so in one option you can see that the values overlap. Then you need to check the range of the measurement. Okay, what can be the range of x? When you check the range, 10 plus or minus 0.6, right? The minimum value will be what? 10 minus 0.6, that will be 9.4 to 10.6 is the range of x, right? When you check the range of y, what is the value? Minimum value is 9.5 minus 0.4, which is 9.1 to 9.9. When you check these values, right, then you go for the options. X is definitely greater than y. If you say that, definitely it is not possible, right? You can't say that because the values are overlapping. So this is wrong answer. Y is definitely greater than y. It is also wrong. So uncertainty is too large to compare. No, here this option is correct. You check this option, the values overlap and may be equal, right? Can be equal. So this is the correct option, C. Okay, I hope you got this right. The next question, we will move on to the fifth question. A vernier caliper has zero error of 0.02 centimeter. The zero error is given. Which statement is correct regarding the percentage uncertainty? So percentage, with respect to percentage uncertainty, which of the following statement is correct? Okay? This type of question, you need to read all the options, okay, and eliminate all the possible wrong answer. Then you conclude. First option, zero error increases percentage uncertainty. Zero error, actually it is with a systematic error, right? In my video, systematic error versus random error, I have explained the theory clearly. If you have doubt, just go and watch that video. Percentage uncertainty is related with random error, right? How to calculate the percentage uncertainty, the whole procedure I have explained in that video. If you have doubt, you can go and watch that video, okay? So zero error increases percentage uncertainty. Zero error, no, this is not possible. Zero error is only with a systematic error. It's not related with the percentage uncertainty. Zero error decreases the percentage uncertainty. Then again, it is wrong. Then zero error affects the accuracy, but not the uncertainty. So we have some doubt in this option. We'll keep it. The next option we will check. Zero error include the random uncertainty. That is also wrong, right? Zero error not related with the random uncertainty. So the possibility is zero error affects the accuracy, right? Zero systematic error will affect the accuracy of measurement. In the theory, I have explained that, but not the uncertainty. So this one will be the correct answer, C. Okay, C is the correct answer. If you got all the 5 questions correct, means your uncertainty calculations, your uncertainty concepts are good. Now you can practice more uncertainty questions to improve your knowledge and accuracy. In the next video, I will explain the concept of principle of homogeneity, which is a high yield topic from physical quantities and measurement. In that video, I will explain all the step-by-step analysis for principle of homogeneity question, how to solve it. I will explain everything with the 3 questions. You practice those 3 questions and you strengthen your concept in principle of homogeneity. See you in the next video. This is Sanal from Hilbody classes. Thank you.